There we go.
All right, so this morning what we'll do then is we'll go through a few of these trig PMIs together. G'day Max, I'll get us started, and I've got a sheet for you, mate. Thank you, trig PMI. And see how we're feeling. You might feel confident enough to move on and have a bit of a go yourself. You might think we can do a few together. We'll see how we go. All right, so the first one we've got that you guys have on your page is the sine theta plus sine 3 theta. Very good. Okay, so I'm going to get straight into the proposition. P of n, the statement. P of n is, remember, this is always our first step, isn't it? We do have to go.
I don't know how to silence this phone.
Throw it out the window.
New phone.
That's going to be really annoying.
Got a new subscriber for the YouTube.
Okay.
Oh,
It's your biggest fan.
oh, poor thing.
I knew you've been soaring to new heights.
How did it even get in this?
Okay, here we go. P of n is sine of theta plus sine of 3 theta plus sine of 5 theta plus sine of 2n take 1 theta. You're very welcome to expand that at any stage. Okay, and that's equal to...
Can I borrow a pen, please?
Oh, if you asked me last week, I would have had one for you, but I've lost my other two.
Max, you're late and you don't have your stuff.
Yeah.
Oh wait, I found it.
Cheers.
Okay, and then we'll just say for all n is a positive integer. Okay, so step one, make the proposition. I'll just shut the door here. Okay, step two, we've got a test. Remember, I've described it as state, right? State, test for n is 1, okay? Or it always has to be the lowest value. Sometimes we have n is 0 is the lowest value. Sometimes we have n is 2 is the lowest value. So you just have to have a look, what's the lowest value? Test for n is 1. And so the left-hand side, you can either just grab the first term that they've got there, or you can plug an n is 1, because we're using n is 1 for the lowest case, into this formula, and you'll end up with the same thing anyway. The left-hand side is sine theta. Okay? On the right-hand side, we have 1 take cos 2n theta. Now, n is 1, isn't it? n is 1, so that's 1 take cos of 2 theta. And so at this stage, we should be looking at our formula sheet on 2 sine theta. We should be looking at our formula sheet and we're going, I want to end up with sine theta. I'm trying to manipulate this to end up with sine theta. And so we're going, I need to somehow adjust this cos 2 theta. So if you're having a look there, it's about halfway down the circular function section, cos 2a, and there's 3 possible things that we can plug in there. I'm also looking at the denominator, which is sine theta, and I'm going, if I plug in a sine theta, I may be able to get rid of that denominator there. So we've got 1 take cos 2 theta. We also know that you might need to just try it a bit. You might just need to mash it a bit and try it with each of them. Now, the one we are going to use is the middle, the top one, okay? So I'll explain why when we get to it. So we have cos squared of theta take sine squared of theta, all on top of 2 sine theta. Okay, so I'm going to process this a little bit now. This negative is going to distribute, so I'll do that first. We have 1 take cos squared theta plus sine squared theta on top of 2 sine theta. And whenever we have a 1 and like a minus cos squared theta or a minus sine squared theta, we should remember the Pythagorean identity, which is cos squared theta plus sine squared theta is 1. And so we can rearrange that such that we have sine squared theta is 1 take cos squared theta, all right? Or we can rearrange it as the alternative form as well. So this can be simplified to sine squared theta. Okay, and because we can simplify it to sine squared theta, we can collect like terms. We're going to have a common denominator that we can cancel. We can start to see there's a solution here. So 1 take cos squared theta, I've said is going to be sine squared theta. At the bottom we've got that 2 sine theta. Now, I've got one lot of sine squared theta plus another lot of sine squared theta. I've got 2 lots of sine squared theta. Okay, we've got a squared on top of a. The 2 will cancel, one of the signs will cancel, we're left with sine of theta. The left-hand side is equal to the right-hand side, therefore P of 1 is true. Alright, now with the trig ones, sometimes this proof here, this part here, can get a little bit tricky. Alright? And it doesn't matter, like if you can't crack that it's true for n equals 1, you can still move on to all of the other steps, right? You can still get marks for the other parts. Remember, in a test or exam, your goal is just to maximize the amount of marks you're getting. So if you can't crack this part or you can't see it, doesn't matter, move on. You won't get the marks for that part, but you can still get them for the later subsequent parts. All right, so test method is 1, done. We've done the test, we're up to the assumption. We're going to assume that P of K is true. Now, P of K is the exact same as our P of M proposition, except we use the letter K instead of N. Let's see if I can find a darker marker. P of K is sine of theta plus sine of 3 theta plus sine of 2k take 1 theta. And our assumption is that it's equal to 1 take cos of 2 theta, cos of 2k theta on top of 2 sine theta. Okay, that's our assumption. Alright. Now, let's prove P of k plus 1. So we're on to the proof. We can go consider P of k plus 1. Now, I'm going to make the P of k plus 1 statement, and I'm going to be quite explicit here about how we should notate this proof component. So, again, we're stating what we have. Sine of theta plus sine of 3 theta plus, and then we have sine of the P of k term.
When you're doing assume P of K, stating that you don't have to write for all n is e again.
For all k.
For all k is
For all
e,
k, yeah.
you do.
For k is an integer.
Yeah.
Assume it's true for k is an integer. Good. Sine of theta plus sine of 3 theta plus sine of, and we're up to 2k take 1. Okay, so we've got the k term, that's k, but remember we're considering P of k plus 1. So we need to add in the next term in the series, which is exactly what we've got here, except we put k plus 1 where k is. In brackets, because it's going to, the product of the two is going to distribute. Okay, so we've got the first term, the second term, all the way up to the kth term, and then we have the k plus 1th term. Now, if it's true, if P of k plus 1 is true, we can state it over here so we know what we're aiming towards. This writing here is not a necessary component. We don't assume it's equality, we have to prove it's equality. And so if it's true, it's going to be this one here. 1 take away cos 2 k plus 1 in brackets, theta, on top of 2 sine theta. If it's true, that's what it will be. Okay, now we have to manipulate the left side, we have to manipulate the right side to show that they're equal, to demonstrate that this proposition is true. So we're going to take the left-hand side, and I'm not going to restate it as it is. I'm going to perform that substitution of P of K straight away. Remember, if P of K is true, then this whole thing is the P of K term, isn't it? So this is where we're going to perform the substitution. This is P of K. We stated P of K down here. If it's true, this is what P of K is. 1, take away cos of 2k theta on top of 2 sine theta. Alright, our assumption is that P of K is this. Okay, on to the next term. Now I am going to expand this a little bit for now. So we'll have 2k plus 2 take 1, and that's all multiplied by theta. We'll do it in a couple of steps. So here's our P of K, here's our K plus 1th term. All I've done is distribute the 2. We can collect that and distribute the theta. It's going to be 2k plus 1, and then we can distribute the theta. So let's do that in our next step. So we're going to have sine of 2k theta plus theta. Now, we want to collect them somehow, right? Remember, this is the left-hand side of the pk plus 1 term. We need to manipulate this somehow so that we end up with this. So we need to combine them somehow. Now, whenever we want to combine two terms, they must have the same denominator. We can't add those because they don't have the same denominator. We need to make them have the same denominator. Remember, we can do anything we want, all right, as long as we're not changing the value. So I'm going to multiply this one by 2 sine theta on 2 sine theta. Okay, the denominator here is 2 sine theta. 2 sine theta divided by 2 sine theta is 1. It's the number 1. We're not changing the value of this. Anything times 1 is itself. We're not changing its value at all. We're just changing the way that it looks. So that's a legitimate operation. Okay? What we're doing is we're giving this the denominator 2 sine theta. Now I'm going to go a bit slow here. I'm going to do a couple of extra steps just to really draw out exactly what's happening. So this step here is one that you could skip. I'm just showing you what's going on with the denominators. Now I'll put the 2 at the front as the leading term, and it doesn't matter which order these signs go in because they're multiplying. 2 times 3 is the same as 3 times 2. It doesn't matter what order we put these in, but I'll just keep them in the order we've got. All on top of 2 sine theta. Okay, so these have the same denominator, right? Which means we can bring them together. Okay. So we have 1 take away cos of 2k theta plus we've got 2 sine 2k theta plus theta sine of theta. And all of that is on top of 2 sine theta. All right, now we need to perform some substitution. So I'm looking and I'm going, that looks pretty close to what we sort of need at the top, right? We've got the denominator right, so I'm looking, where are we going with this? This is what we're trying to get to, the denominator, we've got it. We don't need to mess with the bottom at all now, we can basically ignore the denominator. This term's right, which means we need to adjust this somehow. So I'm looking along and going, what's a substitution I can perform for this? So have a look down your list and you'll see, closer to the bottom, we've got 2 sine A cos B, 2 cos A cos B. We've got 2 sine A sine B. Okay? 2 sine A sine B. That's the substitution we're going to perform. I'll write that one up here. 2 sine A sine B goes to cos of A take B, take cos of A plus B. Okay, so let's very clearly denote what corresponds with A, what corresponds with B. I'm going to describe this whole angle, the first whole angle, that's angle A, and this is angle B, right? And so we're just going to perform the substitution in the next step. So that will give us 1 take cos of 2k theta plus, all right, 2 sine A sine B goes to cos of A take B. Cos of 2k theta plus theta take theta. The thetas will cancel. We'll just be left with 2k theta cos of A take B. And then we have to take away cos of A plus B. Okay, 2k theta plus theta. That's going to give me 2k theta plus 2 lots of theta. Now, all of this is still on top of 2 sine theta. Now, just one shortcut you can take, and this can save a bit of space in the exam scenario and so forth, is that 2 sine theta. I can just bring that out the front and write that here. It's multiplying everything, right? Okay? It's like, all I'm doing is if I have x on top of 4, I can write that as 1 4 times x. That's all I'm doing. I'm bringing it out front. And that saves you having an enormous long. Does anyone know what this line's called? The divising line.
The divising line.
No, it's called an ampersand. I think.
You think?
I'm pretty sure, yeah. All right. So, where are we? We're here. We've processed that. Look at this. These are going to cancel. Minus cos 2k theta plus cos 2k. They're like terms. We're just going to get rid of them straight away. And in fact, we are there. We are there because all we need to do here is factorize this a little bit. Okay? We can see that 2 and theta are common to both of them. And so if we pull 2 and theta out the front, we're going to have k plus 1. All right, so we're there. So we'll state that. I'll do it here, and then I'll do my explaining step at the bottom, which equals 1 take away. We're left with cos of 2 times k plus 1 theta. Okay, if you expand this 2k plus 2, theta distributes, you get exactly what we have there. So we can factorize it, and all of that's on top of 2 sine theta, which is equal to p of k plus 1. Okay, it's equal to the right-hand side of p of k plus 1. So we started with the left-hand side, we've manipulated it, and we've shown that it equals the right-hand side of p of k plus 1. P of k plus 1 is true if p of k is true. So, this is probably where the hard work lies. Is anyone lost at any stage or got any questions? Looks all okay? Excellent. All right, so let's do our explain step then. Because p of 1 is true, the lowest case is true, and p of k plus 1 is true if p of k is true. Therefore, p of n is true for all positive values of integer n. Okay. So, how do we feel about that? Not too bad. Do you want to do another one together, Max?
Do we denote double angle identities and stuff for the test?
You'll be given this sheet.
I don't have that shit.
It's attached to the 2023 test. Yep.
Cheers.
So what do you reckon? Should we do another one together, or do you want to try it for yourself? What do you reckon, Jeff?
I reckon we ask Jack.
Jack, what do you reckon? It's a little bit annoying. Should we just do one more?
Yeah, do one more
Can
together.
we at least name the verb?
Yep.
I think it wants to be a mathematician.
Okay. So, look, if we have a look at the list that you've got, so I'm just trying to remember the order I put them in because I changed the order to try and make them easier for harder. So, look, question 4 is quite similar to the one we just did. So I'll leave question 4 for you to have a go at. Let's do question 2 together because that's the product one, isn't it? So let's do question 2, which is the cos of x times cos of 2x. That's what you've got for question 2. P of n is cos of x times cos of 2x times cos of 4x times all the way up to multiplying cos of 2 to the n take 1 x, and that is equal to sine 2 to the n of x on top of 2 to the n sine of x. Take 1 for all, and we're told positive integers. Now, have you guys seen this one before? Like, if you have sine of x divided by n, there's a quick way you can simplify this. You've got n at the top, n at the bottom, you can cancel it. 6 will be the answer. So,
I don't have to take 1.
take 1 is true.
Might be there. Did you want to check?
Oh, sorry, we're doing question 2, aren't we?
Yeah, there's no take 1 here.
Huh.
Question
Why has it
3.
disappeared?
Question 3 has a take 1.
Yeah. Oh, sorry. You're correct. There is no take 1. There is no take 1 here. My order's different from yours because I printed it, I did them, and then I tried to adjust them in order of what was most difficult. There we go. That's what it should look like. Good. So let's get into this. We've stated the proposition. We need to prove that it's true for n is 1. So let's go. Test for n equals 1. The left-hand side will be cos of x. The right-hand side will be sine of 2x on top of 2 sine x. So sine of 2x, that's what we need to manipulate. Sine of 2x is a beautiful one because there's only one substitution that we can perform. It is 2 sine x cos x. We've got 2 sine x at the top, 2 sine x at the bottom as a product. Can cancel. We're left with cos of x. Left hand side is equal to the right hand side, therefore P of 1 is true. Okay, so state, test, assume P of k Okay. Consider P of k. All right, so I think we're all pretty happy with the assumption step. We're all pretty happy with the test. So let's move on to the proof for this one then. We've got P of k plus 1, which will be, write it down, cos of x. Two k take 1 x. Okay, that's the kth term. Might use those out. And this is the k plus 1 term, isn't it? Now what would be? It would be 2 to the k plus 1 take 1. The 1s will cancel. You can just go straight to the 2 to the k. That would be your x. Okay, and then if it's true, what we'll have is sine 2k plus 1, sine of 2 to the k plus 1 x on top of 2 to the k plus 1 sine x. Okay, so we make our statement for k plus 1, p of k plus 1, then we perform our substitution, right? This whole thing is p of k. So what do we have as our substitution? We have sine, this is p of k. So what it would become? And then we're multiplying it by this term here, cos of 2 to the k x. Okay. So we need to combine them somehow, right? And we've sort of got, you know, the denominator is approximately right, but we're not done because we've got a k plus 1 there and we've got a k there. These are going to have the same denominator already because they're multiplying. We're not adding them, they already have the same denominator. It's just the top times the top, the bottom times the bottom. So, like if I can just restate that, this is what it looks like. Sine of 2 to the k x, cos of 2 to the k x. All on top of 2 to the k sine x. And so we need to perform substitution for sine A cos B, all right? Or it can be written around the other way, cos A sine B, it doesn't really matter. And if you're looking down the list, the one you will see that closest resembles it is the one we used before, I think, 2 sine A cos B. Okay, 2 sine A cos B equals sine A plus B plus sine of A take B. Now it almost resembles it, but it's slightly different. Okay? It's slightly different. I mean, A and B are the same. The angles are the same. We don't have this 2 out the front. Okay, so I'm looking specifically at the numerator. Right? We don't have this 2 out the front, but we do have it out the front here. Now that's an easy, we have an easy solution for that. Okay? If this identity is true, if 2 sine A cos B is equal to this, well then sine A cos B is just equal to half of it, isn't it? And in fact, this might be listed lower down here as an alternative arrangement. No, it's not. Sine A cos B. Okay. Now, when you're looking at this, right, this half at the bottom, if I'm multiplying this by a half, I have that 2 at the bottom. Okay? And that's going to allow us to collect it. So let's perform the substitution first. So we've got sine A cos B. So in this circumstance, A and B are the same, which won't always be the case, but A and B are the same. And so we'll just perform this expansion. This is what it expands to. It becomes half, okay? And we have sine of A plus B. So that is 2 to the k x plus 2 to the k x. Angle A plus angle B. Sine of angle A plus angle B. I'll put that big bracket out front. And then we we have plus sine of angle A, take angle B. Close the big bracket. Now, remember, all we're doing is we're maintaining the quality of what we have up here. So that means the denominator of this term is still 2 to the k on top of sine of x. 2 to the k of sine of x. Sorry, 2 to the k times sine. Okay, we're there. Like, all we need to do is process this a little bit and we've got our answer. So, I'm looking firstly at this term, 2 to the kx, take 2 to the kx. They're going to cancel, right? That cancels, that cancels. And so we have sine of 0. What's sine of 0?
0.
0. Okay, think of your unit circle. Sine is the y values. Sine is the y values. If the angle is 0, then they're talking about this point here. This point here has a y value of 0. Sine of 0 is 0. So this whole thing is disappearing. Let's state what we've got left. At the top I've got sine of 2 to the kx plus 2 to the kx. 2 to the kx plus 2 to the kx. Alright, so I'm going to do this in a few steps again. And at the bottom we have 2 times 2 to the k times sine of x. Alright, so we're just trying to make it look like what we've got over here on the right hand side. I don't think it's enough to just state the answer now. Let's really show why it's true. At the top, I've got 2 to the k of x plus 2 to the k of x. Another way I could write that is I've got 2 lots of 2 to the k of x. All right? It's like saying if I have x plus x, another way you can write that is I've got 2 lots of x. I've got 2 to the k of x plus 2 to the k of x. I've got 2 lots of 2 to the k of x. Okay. And at the bottom, here's what we're going to do at the top in the next step. 2 times 2 to the k. These have the same base. These have the same base. What's the power here? It's 1. 2 to the 1 times 2 to the k. You can collect them by adding the powers. So at the bottom, we're going to have 2 to the 1 plus k. K plus 1 doesn't matter what you're writing. Sine of x. And we're going to repeat the same at the top. Here we have 2 by itself. Well, that's just 2 to the 1. 2 to the 1 times 2 to the k. 2 to the k plus 1. We add the powers together because those terms are multiplying. They have the same base. 2 to the k plus 1 of x. All on top of 2 to the k plus 1 sine of x, which is the right hand side of p of k plus 1. Okay. Proof complete. Explain. Because p of 1 is true and p of k plus 1 is true if p of k is true, therefore p of n is true. There we go. Alright, so, yeah.
Where you multiplied it by the half in the brackets, I multiplied it by 2 on 2. Is that alright? So I got...
Yeah, that's fine. Yeah, performing the same operation. Yeah, absolutely. Yeah.
Sweet.
Yep. Yeah. So there's lots of paths you can take, right? Yeah, and you might find a more succinct way of getting there. Yeah, it's just like when we get to conjecture problems and methods as well. So there's a couple of paths you can take. This one's fine. What Max you've done, that's absolutely fine as well. All right. So I'll stop there, guys. Let's get you guys to have a go at one of them. Now, I've got 5 listed on this sheet, right? Now, I won't ask the last one in a test. I've just put it there to, for one for you to practice. That's quite a nasty one. So, yeah, you won't have that one in the test. I said there's really only 3 I can ask, right? And question 1 and question 4, I think it corresponds with for you guys. Question 1 and 4 are quite similar, so I'm saying they're pretty well the same question. So you could, any of those except 5 you could have. So let's get you guys to have a go. Why don't we all do question 4, because that's quite similar to what we've done. Get your confidence up and then have a go at question 3. Okay, so let's start with question 4. Let's get you guys to have a go at it.